Hello, students, and welcome to our snowy lesson today. I hope you have power today, and I hope your internet is working. So, let's get started. It's February 1st. Welcome to February. So, we're going to start with our do now. We have a prompt about relationship deposits. Our objective today will be to continue learning about real numbers. Our essential question: what is an irrational number? What are rational numbers? And how can we further classify the rational numbers? Our assignment will be to answer our do now in teams. We will watch today's video, and we have 2 pages on real numbers today to work. When you're done with that, we will answer our exit ticket, which I'll show you below, and make sure that you show me your completed work. Of course, if you have internet issues or something like that, you can always email me your completed picture of your completed pages later. So for our exit ticket, we will define integers, whole numbers, and natural numbers, all of which are rational numbers. Again, so important to show me your work, students. For homework would just be if you haven't finished your work, you can finish it for homework. Let's make sure our cameras are on, that you respond when your name is called at the beginning, middle, and end of the period, and that you show me your work. And if you have any questions, feel free to email me. A couple of other important notes for the week. Just a reminder that Wednesday we do have a full day of classes, and our map testing starts Thursday and Friday. And we're going to test for the first 2 hours, and then we'll have 7 short periods for the rest of the day. So let's look at our do now. So relationship deposits enhance our relationships with others. Relationship withdrawals, however, can hurt our relationships. Is it possible to remain friends with someone when the withdrawals are greater than the deposits? So I think we do sometimes find ourselves keeping score in our relationships, but I think if we keep in mind, let's keep this relationship strong, it can survive all those withdrawals, those times when things happen that aren't so great. And we've often talked about a good foundation. So if you have that good foundation of trust and honesty, hopefully you can get back to that good relationship. So I'd like you to answer here and put your thoughts about relationship withdrawals. And is it possible to remain friends with someone when the withdrawals are greater than the deposits? We will come back to our exit ticket, but let's get started with our lesson. So the real numbers are the set of numbers which contain all rational and irrational numbers. So it's rational, and we'll learn what that is in a minute, and irrational numbers. So now decimals that never terminate and they have no repetition. Those are the irrational numbers. Okay, so what are irrational numbers? Decimals that never terminate and have no repetition. There we go. Now, the most famous example is pi, which goes on and on forever. And we will have a pi contest this year at Benny Dover, like we had last year, where we will have a contest to see how many digits of pi you can memorize. I usually remember 5, but it goes on and on and on. Another example of a decimal that never terminates and has no repetition, so we don't have that line across the top, would be the square root of 3, or the square root of 5, or the square root of 41. We cannot say something times something equals that in terms of whole numbers. Now, what are the rational numbers? Rational numbers are all the other real numbers. They can be fractions, numbers that can be written as a fraction with a over b, where a and b are integers. And let's remind ourselves what those are in a minute. So decimals that terminate means end, right? Terminator. Or have a repetition. It should be an E. I keep wanting to put an I there. Are rational numbers. So examples. How about 5 over 7 or 1/2? How about 3 or -2? How about 20 over 5, which we would normally reduce to 4? How about the square root of 16? Now, how is this different from these other square roots? Because 16 is 4 times 4. The square root of 16 does equal 4. 0 is also a rational number, as is 2/3. So what are the integers? So the integers are positive and negative numbers, no fractions, no decimals. So we're going to think all the way from infinity, negative infinity, all the way to positive infinity. So let's say we have -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. So all the way from negative infinity to infinity. Those are the integers. No fractions, no decimals. The whole numbers are the positive numbers, but they also include 0. So 0, 1, 2, 3, 4, 5, and so forth. Those are the whole numbers. Now, if you take out 0, but you have all the positive whole numbers, you have the natural numbers. So the only difference between the whole numbers and the natural numbers is that the whole numbers include 0. Okay, so these are rational numbers. The fractions and the terminating decimals are rational numbers, but the numbers that never terminate and have no repetition are irrational numbers, and both the rational and the irrational are all real numbers. Okay, so all of these are called real numbers. They're part of the real number system. So we can further organize the real number system. So if we consider everything here, the real number system. Okay, all of this is real numbers. So we can consider this the irrational numbers. And this would be the natural numbers. And they don't include 0, so then we would have the whole numbers. Then the integers. And then all of these are rational numbers. So let's do some practice with these numbers. So we're asked to name all sets to which each number belongs. So -47 is an integer. I'll abbreviate it int. If it's an integer, it must be a rational number. And if it's an integer and a rational number, it also must be a real number. Now 2 3/8, let's find the decimal form of that. If we put that in a calculator, that is 2.375. Not an integer because it has a decimal, but it is a terminating decimal, so it is rational and real. Now, the number 3, the absolute value of negative 9. Well, the absolute value of negative 9 is 9. 9 is a natural number, a whole number. It is an integer. It is a rational number and a real number. Now, the square root of 23, if we put that in our calculator, that is going to be a decimal that goes on and on and on. So although it is a real number, it is irrational because it goes on and on and on. Now, number 5, 1.5625 also equals 25 over 16. And 25 over 16 is a fraction, so that means it's a rational number, which is part of the real number system. Now, what about 0? 0 is not a natural number, but it is a whole number. 0 is also an integer, but 0 is neither positive nor negative. So 0 is also a rational number, and it is part of the real number system. Now, the negative square root of 64 equals negative 8. So that would make it a rational number. It would also make it an integer, and it's part of the real number system. Now, negative 0.123, we have this repeating sign. So it is not irrational, it is rational because it repeats. So that would be a rational number because it repeats. And it is also part of the real number system. Let's look at the negative 24 divided by 6, which reduces to negative 4. Negative 4 is an integer. It is a rational number. And it is part of the real number system. And the cube root of 8, what that means is what times what times what equals 8. Okay, that's what that means. And the answer is 2, because 2 times 2 times 2 equals 8. 2 is a natural number. It is also a whole number. It is also an integer. And it's rational number. And it is part of the real number system. Let's go on to our last exercise of the day. So we're going to place the letter of each one of these values. So we're looking at the letter in the smallest set that contains the value. So this negative square root of 50 does not terminate. It is not a repeating decimal. That is rational. 3.895b, the smallest it could possibly be is a rational number. It's not an integer, it's not a whole number, it's not a natural number, but it does terminate, so it's a rational number. C is an integer. It's also a whole number, but it's also a natural number. So we'll fit it down there. D, negative 11, is a rational number, and it's an integer. It's not a whole number. It's not a natural number. So we'll put that right there. Negative 4 and 1/5, E, is a rational number. It is not an integer, a whole number, or a natural number. Now, we talked about pi. Pi is an irrational number that goes on and on and on. So that will go in the irrational category. Now, G is a repeating decimal. We have this line above the 7, so that means that is 1.77777, not a natural number, whole number, or integer, but it's a rational number. H, the square root of 196, is 13 times 13. And oops, let's move that. And let's get our board back. Okay, so that is a whole natural number, H. Remember, we always reduce. Okay, I, the square root of 0. Well, the square root of 0 is 0. 0 is not a natural number, but it is a whole number. J, negative absolute value of negative 34. Well, that would equal negative 34, and that would make that an integer. K, 3 to the negative 1 power, that would equal 1 over 3, and that would be a rational number. Not an integer, not a whole number, not a natural number. 27 divided by 9 equals 3, so 3 is a natural number. Now, 7 times 10 to the negative 2nd power would require a fraction, so that would be a rational number. And finally, negative square root of 4. Well, the square root of 4 is 2, so that would be negative 2, and that would be an integer. So we have all these rules. It takes a little bit of time to practice with them, but we will practice over the next few days. Let's go to our exit ticket. Rational numbers can be classified as integers, whole numbers, or natural numbers. So let's put some examples of this. So integers are the positive and negative numbers, starting from negative infinity to positive infinity. So we'll put some of them here. 2, negative 1, 0, 1, 2, 3, 4, 5, and so forth. That's what the 3 dots mean. Now the whole numbers include 0, and then up through infinity. And then the natural numbers are like the whole numbers, but they do not include 0. So that's us getting started. So these are all rational numbers. Rational numbers can also be fractions and decimals. Any decimal that has a repeat with the line across the top is also a rational number. Irrational numbers never repeat. So it just takes a little bit of practice to get used to them. And as always, with practice, you'll be great.